I'll just give you an overview of the tank. It's a stainless steel tank I bought on an online auction site. It's 1400 litres. Yeah, it's going to be obviously vertical and well insulated. It's got 3 inputs. A wood boiler, the 2 9 kilowatt electric elements for excess solar PV, and also the 6 flat panel collectors that I've rebuilt to go on the roof with the solar coil mounted in the bottom of the tank. Yeah, so the domestic hot water goes in the very bottom. It's mains pressure, so it'll have a copper coil. I'm not sure whether to use 19mm or 3/4 or 7/8 copper tube yet, but there'll be at least probably 54 metres of copper tube in the tank for that. I've built the solar coil, which I'll show you in a minute. Yeah, so the boiler, to the boiler feed, from the to the roof panels with the solar coil in the thing, from the roof panels with 6 panels, hydronic heating return from the hydronic panels. I'll probably only have 3 or 4 hydronic panels in the small house, and then the hydronic feed. So this is the hydronic in the centre third of the tank, and moving up we've got the boiler preheat with a wax bypass thermostat, the wood heater, and the feed from the wood heater boiler, and then obviously the domestic hot water at the highest point of the tank. These are 9 kilowatt electric elements, and they're fed from a controller with excess PV that would normally be sent through to the grid, and you can control how much. So I've got a 15 kilowatt solar PV system on the shed, and that will, if I'm not using it domestically, rather than export it, will be used to heat hot water. You've got your solar coil for your low quality heat, and then you've got your higher quality heat to heat it up that last 20 or 30 degrees, the tank. So you've got one at the top, one in the middle third, and you've got none at the bottom, just so I get some energy out of the solar PV, the solar flat panel collectors. I've got a few temperature probes going in here for the solar controller and for the boiler controller, and also a house display. So that'll be just a display in the house. So I'll have a house display showing the bottom of the tank, the middle of the tank, and the top of the tank temperature. So if we come around, I'll show you inside. I was originally going to use heat exchanger coils for all the different circuits, but it just was going to get too complicated and too hard to service and too hard to get all the coils in the tank. So I made diffuser tubes for a few of the circuits. I've drilled holes in different size holes in the diffuser tubes, and I did some testing on the diffuser tubes, and I'll just show that video now. I'm trying to not stir up the water too much to try and maintain some sort of stratification. So the hottest water's at the top of the tank and the coldest remains at the bottom. Trying not to have it tumble too much. It makes the solar flat panel collectors more efficient by having cold water going, feeding those, and also maintain the hot water at the top of the tank for domestic use. I just want to talk about this wood heater boiler circuit a little bit more. So this is the boiler preheat. This is the feed from the hot out from the boiler. Down here we've got the bypass thermostat, and the idea of this is to prevent condensation in the heat exchanger in the wood heater. When you first turn the pump on, it feels the water jacket at the back is cold because it's only on the flue, and it preheats the water, maybe 60, 65 degrees above the dew point. And once the pump's on, it just pulls water from the top quarter of the tank. And until the water gets to 72 degrees, or whatever thermostat I'll put in this, then it starts drawing the cold water and mixes a little bit from the preheat and a little bit from the tank, bottom of the tank, to maintain the water going into the water jacket in the flue above 60 degrees, which is the dew point, 62 thereabouts C. So if I put a 72 in there, that'll give us 72 degree water, or a bit hotter, at least going into there. And then it'll start drawing the colder water from the bottom of the tank to maintain the temperature above the dew point in the exchanger, as well as, heating the top of the tank, and then gradually pulling the water, cold water from the bottom, and the hot water will gradually work its way down the tank. This is a form I made to form the copper coils from pancakes, how you purchase them and then roll them into the desired shape. So I made this just out of a sheet of gal, rolled it into a circle and just cut out a circle of concrete as form ply at the top. And just put it, and where I cut the hole out of the form ply, I put the tin into the bottom to hold at the bottom and the top. I just rolled the copper around that to form the shape and the diameter that I wanted. So that's the pancake, how it starts. And this is the finished coil. I've rolled 2 at a time to form, so I could run them in parallel to run, to take the load off the pump. So there's 2 coils in parallel. And this is the finished exchanger I made. So it's just the 7/8 coil, 2 18-metre coils, so it's 36 metres of copper coil, 2 in parallel, with the inlet from the solar panels and the outlet to the pump and then back to the panels. So obviously the inlets and outlets are mounted at the tops of the tubes to assist bleeding, getting the air out of the tube coil, and that'll mount into the bottom of the tank. So I've set up a frame in the yard so it gets the sun most of the day, testing the panel that I rebuilt on the right versus a commercially available panel. It's a few years old now, but it's a full copper panel made by Edwards. I think it's Australian made. The difference is the Edwards one's got 6 riser tubes, and the one I've made after doing a bit of homework, it's got 8. The Edwards one's got a selective coating on the copper absorber plate, whereas the one I've built has only got, and it's an epoxy primer, so it's been Scotch Brighted, and then an epoxy primer, and then a high temp matte black exhaust type automotive exhaust paint applied. It's been on there for about 12 months, but I've only just put the panels together. So anyway, I've done some testing yesterday, and I'll just show you some of the results from that. That basically the panel that I rebuilt the core on seems to be 1 to 1.5 degrees hotter and rises faster.